All right, so in the last lecture, we learned about the solutions of a homogeneous linear system of equations. And in this lecture, we will look at the corresponding non-homogeneous system. And the corresponding non-homogeneous system of equations is a representation of the form that I have written here, such that not all the bi terms, that is not all the b1, b2 to bm is equal to 0. So at least one of the terms here, that is b1, b2 till bm, has to be equal to non-zero for this representation to qualify as a non-homogeneous system. And you might also be wondering that why on earth did we investigate the solutions of a homogeneous system of equations in the last lecture. And the reason is that because I'll make an assertion here that if, let's say, x be a solution for the non-homogeneous system, then x can be written as x naught plus xh, where x naught is any arbitrary chosen solution for this linear system, for this non-homogeneous linear system. So it can be any arbitrary chosen solution, and xh is the solution for the corresponding homogeneous system of equations. And let me prove it to you. And before I prove it to you, I just want to remind you guys that each of these things here, x, x naught, and xh, so they are n-dimensional vectors, right? So and each element in these vectors is x1, x2 till xn. Okay, so let's say x be any solution, right, of the non-homogeneous linear system. So we will have ax equal to b. All right, and let's say x naught be any arbitrary particular solution, so let's say, this linear system, this non-homogeneous linear system had solutions like x naught, x1, x2, till whatever. And so let's say we choose any one of them. So let's choose x naught. So then ax naught is also equal to b, and here x can be any one of them, x1, x2, x naught, any one of them. All right, so if we subtract these two guys, we get ax minus ax naught equal to b, right? Sorry, equal to 0. So hence x minus x naught, and let's call this xh. All right, so xh is the solution for the corresponding homogeneous system of linear equations. So basically this shows that that the difference x minus x naught for any solution x and a fixed solution, that is any arbitrary chosen solution, any fixed solution for the non-homogeneous system, is a solution for the corresponding homogeneous system of linear equations, right? So what it basically means that xh will run through all the solutions of the homogeneous, will run through all the non-homogeneous solutions. All right, so this is indeed true. So if this is indeed true, what it basically means that xh, that is the solution for the corresponding homogeneous system of linear equations, is present in all the solutions, in any solution x for the non-homogeneous case. So hence this completes the proof, and the reason also that why we were actually interested in investigating the solutions for the homogeneous system of linear equations. So all right guys, so that's all I had to talk about in this lecture. I'll see you folks in the next lecture.